Hi there. So in this lesson, we'll be learning about number patterns. So I'm gonna walk you through various lessons related to number patterns using Sri Lankan grade 9 mathematics textbook part 1. So this is the first chapter of that textbook. So it will be talking about number patterns. So by studying this lesson, what you will be able to do is you'll be able to develop the general term of a number pattern with the same difference between adjacent terms. So particularly we'll be learning about what this adjacent term means. So we'll be talking about that, and then we'll also have the ability to develop the number pattern when the general term is given. When we know a general term, we should be in a position to devise the number pattern. We should be able to kind of figure out what's the first number, second number, third number, and fourth number, and whatever that nth number is, and so forth. And we'll also be able to solve problems associated with number patterns. Okay, so let's first of all understand different number patterns. And if you look at there are a few examples here. The first one is pretty simple and just repeats the same number here. So it's the same number is getting repeated many times. So obviously by looking at this, we can say the next number is 3. And usually in a number pattern, they'll kind of specify these 3 dots at the end to indicate that this number pattern continues. That means there will be more numbers behind the last number, and so forth. So basically for the first number pattern, we can see that the same number is getting repeated. And the second number pattern, if you look at, it says 2, 4, 6, 8, and 10. You see a pattern already. Each number is derived by adding 2 to the previous number. So 2, we have the first number. The second number is derived by adding 2, which is 4. And the third number is derived by adding 2, which is 6, which is this number. And then you add another 2, you get 8. Get another 2, you get 10. So by looking at this, we know the next number after 10 is going to be 12. So we add 2 for this, which is going to be 12, right? And fine. So that number pattern is quite clear for us now. And let's go to the next one. And so if you look at this number, again, it has 5, 8, 11, 14, and 17. So you see readily a common difference between each adjacent numbers. So you add 3 to 5, you get 8. You add 3 to 8, you get 11. You add 3 to 11, you get 14. And then you add 3 to 14, you get 17. So the next number is going to be, you add 3, you will get 20. So basically it's how these number patterns come by. So if you just look at the other one now, it has similar patterns. So this one is a bit different actually. So it says 2, 4, 8, 16, and 32. It doesn't keep on adding. Like if you add 2 to this, yes, it's 4. But if you add 2 to 4, it should be 8. It should be 6, but rather it is 8 here. So it's not a number pattern that keeps on adding, or it's not a number pattern that has a common difference between two adjacent numbers. Two adjacent numbers means any number that sits side by side, right? And so these two are adjacent numbers, these two are adjacent numbers, these two are adjacent numbers. So difference between those two, that means if you look at the difference between these two, 32 minus 16 is 16. And if you look at the difference between these two, 16 minus 8 is 8. So difference between these two is 8, difference between these two is 16, right? So these two. So by looking at that, we know that this particular number pattern doesn't have a common difference. So in grade 10, you will learn more about arithmetic progression for these kind of number patterns. There are few names that you can use. One is obviously number pattern. There is other name that you can use, something called sequence. We can also say number sequence. And another term that you will come across in mathematics textbooks and mathematical notations and talks is that you get to know about these things as progressions. So, or arithmetic progressions, geometric progressions, these things you will learn in grade 10 and 11. Fine. So, actually, this particular number pattern is what we call a geometric progression. It's not an arithmetic progression. So, arithmetic progressions, these are all three of these are arithmetic progressions, whereas this one is actually a geometric progression, meaning you see this 4 is actually derived by multiplying 2 by 2. You multiply this by 2, you get 4. You multiply this by 2, you get 8. You multiply this 8 by 2, you get 16. And then you multiply this 16 by 2, you get 32. So likewise, the next number of this particular pattern, given this general term agreement that you multiply this by 2, you get 64. So by looking at this, it will be 64. And these kind of patterns are what we call as geometric progression. So we'll learn more about those kind of progressions in grade 11. Fine. So, but just wanted to kind of explain there are different kinds of patterns and progressions and sequences available in mathematics. So if you look at this last fifth one, it says 1 1, 2 2, 3 3, 4 4 and 5 5. It doesn't have a common difference as such, but there is, of course, there is a pattern. And obviously by looking at these, you can definitely say the next two numbers will be 6 6, the other two numbers will be 7 7, and then 8 8 and so forth. So it has a different pattern, and that's how it looks like. And if you look at this other pattern, you see 1, then 2 2, then 3 3 3, 4 4 4. That particular number that you are trying to figure out has that many numbers. When you look at number 3, it has 3 numbers here. 3. If you look at 4, there are 4 numbers here. If you look at 2, there are 2 numbers. 1 is only given once. So obviously by looking at this pattern, we can probably say that the next couple of numbers will be 5 5 5 5 and another 5, because number 5 should be kind of repeating 5 times. So if you look at the next number, it will be 6 repeating 6 times. Something like this is 5 and there is another one. Okay, so these will be the pattern. So but in this particular lesson, we are more interested in patterns that has a common difference, something like this, right? It has a common difference between two adjacent numbers. In another word, we'll be only looking at arithmetic progressions in this particular lesson. So let's move on and see what else we'll have in this particular chapter. Right, so we looked at it. I recommend you read through some of these if you have the textbooks, otherwise you can just follow through me. And we just looked at how these number patterns differ, and when it comes to those arithmetic progressions or number patterns that has a common difference between two numbers, you can find the common difference by subtracting any term except the first term, of course, because the first term doesn't have a previous term, so we will have to subtract the previous term from any term, but the first term doesn't have a previous term. So to find the common difference, so you have to kind of find this number and subtract this. So 10 minus 8 is going to be 2. So we can figure that out by looking at that. Okay, so let's move on. Okay, so when we talk about certain examples, now look at this example number 1. It says, well, the first 3 terms of the sequence with first term 4 and common difference 4. The first term is 4. So what will be the next number then? Because the common difference is given as 3. So the next term will be 4 plus 3, 7. And the next term will be 7 plus 3, 10. So that's exactly what you see here. Okay. And okay, so let's move on. So example number 2, the first 5 terms of the sequence with first term 7 and common difference is minus 4. Common difference can be a negative number as well. So in that case, the first term will be 7, The second term will be 4 less of 7. So 7 minus 4, which will be 3. And the next term will be 3 minus 4, which will be minus 1. And then minus 1 minus 4, which is minus 5. And then minus 5 minus 4 is minus 9. Right. So I hope you can do these kind of calculations, and you should know those calculations by this time. Okay, then we have this common term called general term of a number pattern. So when it comes to an arithmetic progression or a progression or a number pattern that has a common difference, we can derive what we call as a general term for such number patterns. So in grade 9, the expectation is that you should know to derive a number pattern given the terms like the first term and then a common difference and so forth. You should be able to derive it. In grade 10, we'll actually derive a formula for this number pattern, and that formula, once you know that thing, you'll be able to derive the number pattern for any sequence that has a common difference, or basically a arithmetic progression. But we'll be not looking at that particular formula in this grade, so let's go on. So how to derive this number pattern for this particular thing? So now see, you have 5, 11, 17 and 23. So to develop a particular notation to create a number pattern, usually what we call as the first term, we will write it as T1. Term 1. Term 1 for this particular pattern is 5. Term 2, so let's write it in this way: term 1, term 2, term 3, term 4, right? So let's use this way. Term 1 is 5, term 2 is 11, term 3 is 17, term 4 is 23. So by looking at this, we know that term 5 is going to be 6 more than that, because the common difference looks like 6 in this pattern. So it's going to be 29. So we'll have that thing in mind. Okay, so let me, okay, okay, let's write it again. T1 is 5, T2 is 11, T3 is 17, and T4 is 23. So I'm going to use this instead. So fine. So T1, how can you derive it? So we can say the common difference is 6. We can derive this by 6 times 1. So always think in terms of the common difference. And this is 6 times 2, 6 times 3, 6 times 4. Is it right, first of all? No. 6 times 1 is 6. To get 5, you need to subtract 1. Similarly, 6 times 2 is 12. To get 11, you have to subtract 1 from that. 6 times 3 is 18. 18 minus 1 is 17. 6 times 4 is 24, and you minus 1, that becomes 23. Now you see, this 1 is what you see in here in this one. This 2 is here. This 3 is here. This 4 is here. Likewise, if you go and if you look at this pattern, if we write something called Tn, n is something that we don't know. We normally write this notation to say nth term of this sequence. This is the first term, second term, third term, fourth term. Likewise, the nth term, n can be substituted with any other number, like n can be 100, n 100th term. Then, or it can be like 50, n 50, T50 will be 50th term, and so forth. So by looking at this pattern, we can write 6, because this number 4 is what you see here. If it was n, we would write it as 6 times n minus 1. So this is what we call as a common term. So usually we write this as Tn 6n minus 1. When you say 6n, it's 6 times n, right? So this is the common term of this particular sequence. Okay, so let's go down. And yeah, so this sequence is developed, and you can read through it to figure out what's that. So develop the number sequence when the general term is given. So, and Fine. Fine. So let's do this example. Now, sometimes the general term will be given to you. Now, as in this case, the general term is given. So if the general term is given, so the first question says write the first three terms. So basically that means you have to find T1. T1 is 2 times 1 plus 3. 2 times 1 is 2. 2 plus 3 is 5. T2 will be 2 times 2 plus 3, which is going to be 7. T3 is going to be 2 times 3 plus 3, which is going to be 9. So this is exactly what they have given here. Okay, so we know that now, and then let's find the second one. Find the 20th term. Pretty easy, right? So 20th term is going to be T20 is going to be 2 times 20 plus 3. 2 times 20 is 40. 40 plus 3 is 43, which is given here. Okay, so then which term is equal to 123? So basically in this case, they are saying the term is given. So they want to find the n for this. So let's say our sequence or the number pattern is 2n plus 3. If the number was 123, what this n is what the question is. So to figure that out, 2n plus 3, these are like equations. You subtract 3 from both the sides, so then you can take this off. Then 2n will be 123 minus 3 is 120. Then we divide both the side by 2 so that we can take this off. So n becomes 120 divided by 2 is 60. So that's how this 60 came about. Right, so let's go down. So in order to obtain the nth plus 1th term, now they are asking this question, find the nth plus 1th term. So that's how the mathematics game plays around. Now they have given the nth term, so they are asking us the n plus 1th term. How do we derive that? So if we know Tn is 2n plus 3, how do we derive to Tn plus 1? So instead of n, then we need to put n plus 1, and we will write like this, because we have to use this parenthesis because it's a multiplication between these two. So that means, how do you multiply this? 2 times n is 2n, 2 times 1 is 2, and then we have this 3. So the 2nth plus 1th term is 2n plus 5, 2 plus 3. So that's how you derive that. Okay, so then now moving on, so which is what is being explained here, and I'm not going to follow through this example because it's the same kind of example in different way. Okay, so let's figure this out. So complete the table. So we'll do a few examples for this. Okay, and okay, so let's do this. So complete the table. Now this says the general term of the number pattern is 3n plus 1. They have given one example. So let's do this particular one for as we will complete all the 4 columns, right? So the first term when n is equal to 1. So you want to find the first term. So it's quite easy. 20 times 2 times, sorry. So I think we'll have to 20 minus 2 times 1. 2 times 1 is 2. 20 minus 2 is 18. So the first term is 18. And the second term is 20 minus 2 times 2. 2 times 2 is 4. So 20 minus 4 is 16. Third term. So 20 minus 2 times 3. 2 times 3 is 6. 20 minus 6 is 14. So the first 3 terms you can pretty easily write 18, 16 and 14. Likewise, you can complete the remaining table entries as well. So let's come off with this. So the second question is the general term of a number pattern is 4n minus 3, right? The first 3 terms, pretty easy. You can now even mentally do this. I mean, you can calculate mentally as well without writing, but let's let's do it for the sake of completion. 4 times 1 minus 3, the first term. 4 times 1 is 4. 4 minus 3 is 1. Second term will be 4 times 2 minus 3, which is 8 minus 3 is going to be 5. Third term is 4 times 3 minus 3. 4 times 3 is 12. 12 minus 3 is 9. So as you can see, you can verify the common difference between these numbers are 4. Common difference is 4 there. Find the 12th term. So likewise, if you just go to 12th term, so that will be 4 times 12 minus 3. 4 times 12 is 48 minus 3 is 45. So then they are asking which term is 97. So for that, let's just take some space here. Okay, so now they are asking the n value given 4n minus 3, which is 97. Pretty easy, right? 4n minus 3, we have 97. Now because of this minus 3, we should add plus 3 to both sides to make this negate each other. So 4n, 97 plus 3 is pretty easy, 100. And then we have to divide by 4 times which number is 100? 4 times 25. So you can, in another way, you can take it like this. 100 divided by 4, then 4 divided by 4 is 1. So n becomes 100 divided by 4, which is 25. Right. So then we have this other value. Show that 75 is not a term of this number. So 75 is not a term of this number. How do we show that value? So let's say, let's assume it is. So then 4n minus 3 should be 75. Then n should have a number. So let's see. 4n minus 3 plus 3. We add 3 to both sides. So that we can negate that. 75 plus 3 is 78. And now if we divide both the side by 4, this n should be 78 divided by 4. What is 78 divided by 4? 78 we divide by 4. Let's see. 1 and you get 1 there. So you have 3 balance and you bring this 8 down. 38 divided by 4 is 9, but it doesn't divide equally. So we'll always have 2 balance. So in fact, to get that thing, we can get the 0 here. It's actually 19.5. N is 19.5. But in a number sequence like that, can we have something like 19.5th term? We can always have the first term, second term, third term, fourth term, and so forth. There can be anything like 19.5th term. So you can write it down saying fractional terms are not possible with arithmetic progression or number patterns like this. Therefore, 75 cannot be a number, a term in this particular number pattern. So that's the proof of that. Okay, so that's how we just develop it. Okay, let's move on. And so I think I can skip this the third question, because now see, if you look at the third question, it's pretty easy. You can find the first 3 numbers. Finding the fifth term is pretty easy. Which term is 36? Again, you make it 7n plus 1, 36, and figure out what to do with that. And then write the nth plus 1th term. Again, you can pretty easily substitute. So let's just do that. So to figure out the nth plus 1th term, tn plus 1 will be 7. Instead of n, you substitute n plus 1 and then 1. So to get this thing, you multiply these to 7n, multiply this, that's becomes 7, and then we have this 1. So 7n plus 8 is the tn plus 1th term. Fine. So going forward, I think we have similar questions there. Okay, so now we already did this thing previously, obtaining an expression to the general term. We already did that for that example previously. So let's go through a few examples to see how to derive the general term. Okay, so for this, you see for this particular pattern, common difference is 4. So then you should try to write T1 is 15, T2 is 19, T3 is 23, T4 is 27. So the common difference is 4. So write in terms of 4 and then see what you can do. Okay, So common difference is 4, and then let's see, if we just multiply by 4 it's 16, then it's minus 1. Multiply by 4 it's 16, so it doesn't so actually we should use the term here, somehow, and see what to do with that. Okay, so term, if we just multiply by 1, 4, and if we just multiply by this 2, 8, multiply by 3 it's 12, multiply by 4 is 16. So to make 15 from 4 you need to add 11. To make 19 from 8, 4 times 2 is 8, you have to add 11. Similarly, if you just do this thing, you see a common pattern. So likewise, then if you go Tn becomes 4n plus 11. So this will be the number pattern for this particular sequence or number. Yeah. So likewise, you can just do the other way around as well. Let's do a few examples to see the number pattern. So let's take this, looks a bit complex, but it isn't. So the first term is, I'm taking this example. So T1 is 2.5, or you can write it as 2.5 to make it easy. So then the T2 is 4, or you can write it as 4.0. And the third term is 5.5, 5.5 is 5.5. And the fourth term is 7. So if you look at the difference between the second term and the first term, you had to add 1.5. So you had to add 1.5 to 2.5 to make it 4. And 4 plus 1.5 is 5.5. And 5.5 plus 1.5 is 7. So we know the common difference is 1.5. So let's write it in terms of 1.5, these terms, right? So 1.5 times 1 is 1.5, and then you have to add 1 to make it 2.5. That's how 2.5 comes. So 1.5 times 2 is 3, and then you have to add 1 to make it 4. 1.5 times 3 is 4.5, and then you add 1, you get 5.5. So then you multiply by 4, the fourth term, 1.5 times 4 is 6, and 6 plus 1 is 7. So we see a pattern. The first term is this, second term is this, third term is this, fourth term is this. By looking at that, our nth term is 1.5n plus 1. Or you can write it this way, 1.5n plus 1. Or there is another way to write. So 1.5, you can also write it as 3 over 2n plus 1. Usually we write it in this form than in this form, but yeah, whichever form that you like, you can take it as that. Okay, so complete the table in relation to the number pattern, and I will leave that as an exercise for you. And okay, the finding the general term should now be quite easy for you guys to move forward from here. So then let's solving mathematical problems involving number pattern. Now, why do we learn all these number patterns is not just for fun, right? So the thing is, in real world, sometimes we find these kind of patterns. Then obviously mathematics comes to our rescue to learn more about such patterns in real world. So let's get examples of this. So always learn mathematics with these kind of real world scenarios, and that's how you can apply. Basically, we call this applied mathematics. You apply the mathematical principles, theorems and everything to a real world scenario, then it becomes an applied mathematics. So in advanced level, there is a if you learn combined mathematics, there are two sections for that. One is the pure mathematics, other one is the advanced applied mathematics. So applied mathematics will be more of a practical mathematics, where you combine your mathematics skills with some real world scenarios, and physics is in fact in a way a sort of applied mathematics, which you will learn in advanced level if you choose mathematics stream. Okay, so let's look at this example, and then we'll go to few exercises to wrap up this particular lesson. So in this example, if you look at, it says a long distance runner trains every day. On the first day he runs 500 meters. and on each day after he runs 100 meters more than the previous day. So now these days, guys, like all of you, kids run and they do exercises and so forth. For example, if you're doing push-ups, you might be doing just 5 push-ups today, and the next day you might be thinking, I'll do 2 more the very next day. So the next day you'll be doing 7 push-ups, and the next day you will be doing 9 push-ups. So these are like real world scenarios. Now, end of the day, when you do the numbers, it is a number pattern. So likewise, in this case, it's about a long distance runner. A long distance runner is on his first day is running 500 meters, and in the second day he'll be running 100 meters more, which means he'll be running 600 meters. So here they're asking in the first question, write separately the distance he runs on the first 3 days. So first day 500, second day he will be running 600, third day he will be running 700. So that's what it means. Okay, so then find the general term Tn for the distance he runs on the nth day. So now you know how to derive the nth term of a number sequence. So let's do it, right? So we know T1, so let's write it here. T1 is 500, T2 is 600, T3 is 700. So let's write in terms of the common difference, 100, right? The first term is 100. If you just multiply by 100 times the term number 100, how much you need to add to 100 to get 500? You need to add 400. So 100 times 2 is 200, 200 plus 400 is 600, 100 times 3 is 300, 300 plus 400 is 700. So likewise, nth term is going to be 100n plus 400. So this is the nth term. Pretty simple. So as you can see, so it is clear that the distance run on the 20th day is represented by the 20th term. Okay, so how do we find that? So okay, 20. So we should find. So the third question is all about find the distance he runs on the 20th day. So then it's easy. T20 should be 100 times 20 plus 400. 100 times 20 is 2000 plus 400 is 2400 meters. Remember, it's meters. And if the question is to kind of derive this from kilometers, then how many meters are there in a kilometer? 1 kilometer is equal to 1000 meters. So if it's 2400, you have to divide that by 1000 to get the kilometer value. So the kilometer value will be, so for 2400 meters, it will be 2.4 kilometers. Okay, so these should be pretty easy for you guys. And on which day does he run 3 kilometers? So 3 kilometers is what? So now remember our Tn 100n plus 400, this particular equation or this particular term is in meters. So when the distance is given in kilometers, you have to always use the meter value. So in the next question, it was given for us 3 kilometers. So 3 kilometers is 3000 meters. So let's write 3000, 100n plus 400. So now if we just take this 400 to the other side, so 3000 minus 400, this should be second nature for you very soon. So you just subtract these two. 3000 minus 400 is 2600, 100n. And then to get 100, you can just divide it by 100. So n will be 26. So he will be running 3 kilometers on the 26th day. That's what it means. Pretty easy. Okay, so now there are quite a lot of sums in this exercise 1.3 section, right? So I'm not going to kind of walk you through all of these sums, and let's first look at just one and then wrap up this lesson for today. So yeah, let's look at question number 3. So let's carefully read that first. So the question says, on the day that their school celebrated annual savings day, Yasmi and Indunil start saving money by putting rupees 100 each into their respective savings boxes. After that, they put money into their savings boxes once a week on the same day of the week that they started saving money. So that means if they have started saving on Monday, the following Monday, they add certain amount to their boxes, respective savings boxes, and so forth. And then that's about the question. So Yasmi put rupees 10, and Indunil put 5 rupees each week into their respective boxes. How much does Yasmi have in her savings box in the 5th week is the first question. And the second question is about how much does Indunil have in her savings box in the 10th week. And the third question is about at the end of 50 weeks, 50th week, both of them open their savings boxes and check the amount that each has saved, basically. So how much more money has Yasmi saved than Indunil in the 50th week is the question. So let's look into this. It's quite easy. So let's first look at Yasmi's account, right? So let's start looking at it. So in the first week, second week, third week, fourth week, and fifth week. So let's say that. So Yasmi will have 100, and then she will have 110, 120, 130, and 140. So because she adds 10 rupees each every week, right? So then her savings at the end of fifth week will be 140 is what that means. So we have the answer for the first question already, but let's devise, because this is an arithmetic progression. This is a progression or sequence with a common difference. So let's figure out a common or general term for this. So if we just write it by 10, because that's the common difference, 10 times 1, then we'll have to add 90, right? So 10 times 2 plus 90. So this is 10 plus 3 plus 90 is what 120 is. So likewise, you can easily see 10n plus 90 will be the nth term of Yasmi's savings and so forth. So Indunil's savings will be something similar. So let's see. So I'll just write it down here below. So she is also starting with 100, but next week she will have 105, 110, 115, and 120. So if you just write it by 10, so it will be 10 times 1. So we'll have to add, in fact, it's 5, right? So her common difference is 5. 5 times 1 is 5. So we'll have to add 95 to get 100. So 5 times 2 is 10. 10 plus 95 is 105. 5 times 3 is 15. And 15 plus 95 is 110. So by looking at this, we can say 5n plus 95 is the general term for Indunil savings. The second question, so for first question, we already have the answer. If we just substitute 5 here, 5 times 10 is 40. 40 plus 90 is 140, which is this term. So Indunil's question is about like what will be her saving in the 10th week. So we'll get this one here. So 5 times 10 plus 95. 5 times 10 is 50. 50 plus 95 is 145. Third question is about what's the difference of their savings in 50 weeks. So let's find for Yasmi. So T50 will be 10 times 50 plus 90, because we are using this term. So 10 times 50 is 500, 590, 590. So she will have 590 rupees by 50 weeks. And Indunil will have, let's say, this is her term. So 5 times 50 plus 95. 5 times 50 is 250. 250 plus 95 is 345, right? 5 times 50 is 250. 250 and 95 is 345. So the difference between 590 and 345, how much more would Yasmi has saved than Indunil? So we can find 5 difference. 8 times 8 minus 4 is 4. She would have saved 145 rupees more is the question. Well, so I'm going to wrap up this lesson from here today. So I would highly recommend that you follow along the remaining exercise questions to practice more on these type of number sequences. And I'll meet you in another lesson very soon. Thank you.